Hello, I am Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology. In this video, we will try to understand the basics of the node analysis method or node pair analysis or node voltage analysis. Now, first we will try to understand a statement and then we will see the explanation part and some examples. Now here I will read the statement one by one. In this method, nodes are marked. This method is different from the mesh analysis method. The concepts are a little different. Here in this method, the nodes are marked. Means we have to mark the nodes. As I discussed in the previous videos, what is a node point? Node is a point at which three or more than three branches meet together. Now here in this particular figure, here this is 1, 2, 3. Means this should be the node point. This should be the node point. This should be the node point, and this should be the node point. Here, what is the first case? In this method, nodes are marked and one common node is selected as a reference node. There is no restriction. We can select this node as a reference here, this node as a reference, maybe this or maybe this, depending on our requirement. But generally, on the bottom side, whatever we have a habit. That's why at the bottom side, we will select its node as a reference and whose potential we will assume it as 0 volt. Other nodes are marked with the potentials VA, VB and VC so on. First, we will mark the reference node or common node. Now here, whenever we don't have any element between the two nodes, this is one node and this is other node, we don't have any element between these two nodes, then these are not the two separate nodes. This is single node itself. Means if the figure is modified something like this branch may be connected something like this, here it may be connected in place of this connection. If we have the connection something like this is one point and this will be treated as one common node or a single node itself. And I will assume this node as in this particular figure we have the three nodes. Out of that, one is the reference node and I will assume this node as a ground node or reference node. His potential, we will assume it as 0 volt. We can assume this has a ground node or this has a ground node depending on our requirement. But here generally we will assume bottom node as a ground node. This node with potential VA and this node with the potential VB, because B node, A node with potential VA, B node with the potential VB. These are the minimum requirement. Now here in this case, nodes are marked. One node is selected as a reference node, other nodes are marked with potentials. Equations are formed for these node voltages by applying KCL to each node. Now we have to apply the KCL to each node. How is the KCL? In case of the previous method, that is in case of the mesh analysis, we have the three meshes. One mesh, we will assume separate current for mesh 1, mesh 2 and mesh 3. It is not actually current like that. But here, that is a theoretical method in which we are assuming the separate loop currents. But here in this case, we have to assume separate current for the separate branch. And what is a branch? Branch is nothing but path between any two nodes. This is branch. Now here is one node or here is one node. This complete path is one branch. For this single branch, we have one current. Second branch, we have the separate current. Third branch, we have separate current. Fourth branch, we should have a separate current. And fifth branch, we should have separate current. Means in this case, we have to assume separate current for the separate branches. Again, the direction of the current is not important. Here, it is I1. That is forward. You can assume the reverse also, that we will see in the explanation part. This current may be the I2. Third current here, it may be the I3. This current downward, maybe it is I4. And last current, we will assume it as a I5. What is the first case? We have to assume separate current for the separate branches. In case of the nodal analysis, it is not the mesh analysis in which we are assuming the separate current for the separate mesh. Now here, we have to find out the equations for node voltages, that is VA and VB. Here this is 0, that's why we need the two equations here to calculate VA and VB. This we have to apply the KCL at node A and KCL at node B, and we have to prepare its equations. Now here, I will start with applying KVL to the node A. KCL to the node A. Here applying KCL at node A. If we are applying the KCL at node A, what is the KCL? Incoming currents is equal to outgoing currents. Now here in this case, what is the incoming current? Incoming current is I1. Look at here. For this node, I1 is incoming, I2 is outgoing, I3 is also outgoing. This equation will be I1 is equal to I2 plus I3 is the equation. Now here we have to substitute the values of the I1, I2 and I3 in terms of its node potentials, and then we are able to get the equations. Now how to calculate that value? Here I will take a simple example. If this is the resistance R having its value as a 10 ohm, here the potential at this point is the 20 volt and potential at this particular point is the 10 volt. Then we have to calculate current in this branch, suppose, or current in this resistance, which is I. How we will calculate this I? How we will calculate this current? We will calculate this current. We will calculate this current by using simple technique: voltage across resistance divided by its resistance. Now here voltage across resistance will be potential difference. Here is a potential 20, here is a potential 10, that is 20 minus 10 divided by 10. This it is 20 minus 10 divided by 10, which is nothing but 10 divided by 10, which is equal to 1 ampere. The same concept we will use here to calculate or to find out the values of the currents I1, I2 and I3 and then remaining terms. Now here in this case, if we are calculating the value of the current I1 here, the I1 is the current in this branch, I1 is the current in this branch. Here is the potential V1 and here is the potential VA. Means I1 will be V1 minus VA divided by its resistance, which is R1, which is equal to. We will find out the value of the current I2. I2 is current in this branch. Here is a potential VA, here is a potential which is 0. That is VA minus 0 divided by its resistance, that is VA divided by its resistance, which is R2, plus I3. I3 is the current in this horizontal branch. That is VA minus VB divided by its resistance, that is VA minus VB divided by its resistance, which is R3. Now here, if we are simplifying this equation, its equation will be something like this. That is V1 upon R1 minus it is VA upon R1, which is equal to it is VA upon R2 plus it is VA upon it is R3 minus it is VB upon it is R3. Now we will separate the terms. I will shift this VA to the next side and we will take that VA as a common. Means it is VA in bracket. It is 1 upon R1 plus it is 1 upon R2 plus it is 1 upon R3 minus it is VB upon R3, which is equal to V1 upon R1. This is the equation number 1. Now we have this equation number 1 for the node 1. Similarly, we will apply the KCL, that is Kirchhoff's current law, at the node B and we will find out its equation again. Now here in this case, this is the node A, and here if we are applying the KVL or if we are applying the KCL, that is Kirchhoff's current law, at the node B, in that particular case equation will be something like this. Now here I will apply the KCL at node B. Here KCL at node B. If we are applying the KCL at node B, how is the KCL or how is the Kirchhoff's current law? Incoming currents is equal to outgoing current. This is incoming, this is outgoing and this is outgoing. This equation will be I3 is equal to, it is I4 plus it is I5. Then here, in the similar way, calculate the value of the I3, which is again VA minus VB divided by its resistance, which is R3. Thus, VA minus VB divided by its resistance, which is equal to I4. I4 is the current in this branch. I4 is the current in this branch. That is VB, potential here is 0. That is VB minus 0, which is VB upon its resistance, which is R4. Then plus I5. I5 is the current in this branch. That is VB minus V2. This is VB minus V2 divided by its resistance, which is R5. Now here in this case again we will separate the terms and we will find out the equation, that is VA upon it is R3 minus it is VB upon it is R3, which is equal to VB upon it is R4 plus it is VB upon it is R5 minus it is V2 upon R5. We will separate the terms. I will shift these two terms, VB and VB, on the left hand side. Then VA upon it is VA upon R3 minus VB is a common, that is 1 upon R3 plus it is 1 upon R4 plus it is 1 upon R5, which is equal to minus V2 upon R5. This is the equation number 2. Now we have the two equations and the two unknowns, and solving the two equations simultaneously, we are in a position to calculate the values of the potentials which are VA and VB. And if we know the VA and VB, we can calculate current in any branch. Just like I1 will be V1 minus VA upon R1, we can calculate if VA is known. I2 we can calculate if VA is known. We can calculate I3 if the VB is known. Similarly, we can calculate I4 if VB is known. We can calculate I5 if the VB is known. Means in this way, we can calculate current in any branch. This is the concept of that is node analysis. But here, I have considered only simple things. Now here, I will move towards some of the complicated things. Now here in this case, what I have taken, this current, if I will take it as something like this. Here it is, this current is I1, this current is again I2, here it will be I3, this will be, it is I4, and this will be I5. I will assume the reverse directions also, and then we will see. Now here, if we are, I am not discussing about how to calculate, how to prepare the equations that you know, how to calculate the currents that I will discuss. How to calculate the I1. Now here I1 will be potential difference divided by its resistance. Now here, what is the potential here? V1 minus VA. V1 minus VA divided by its resistance R1. Not R1. Because I have, in the previous example, we have only one resistance, that is R1. But here, in this case, this is the complete branch, that is R1 plus R3, because we have to consider the resistance of the complete branch, which is the resistance of the complete branch. In this case, it is R1 plus R3. This will be the case. If direct, and we are calculating the potential from here, this is 0, we are traveling from the negative to positive, that's why it will be the plus V1, then minus VA divided by its resistance. Now here we will see how will be the I2. How will be the I2 if it is downward? I2 will be VA, we are traveling from positive to negative, that is minus VA minus its potential is V3 divided by its resistance, which is R2, and here potential is 0, that's why no need to consider again. If we are finding the value of the current I3 here, in this case, here is the potential VA, here is the potential VA, this is the battery. For battery we are traveling from positive to negative, which is minus V5, then minus VB divided by its resistance, which is R4. This will be the value of the current I3. If we are finding the value of the current I4 here, I4 in this case will be VB, negative to positive, plus VB plus its voltage is V4 divided by resistance of this complete branch, which will be the R5. Now how to calculate the current I5 in this case? If we are finding the value of the current I5 here, which is equal to we are calculating this current. Here, VB is the potential, VB. Then for battery, we are traveling from the negative to positive. That's why it is a plus, V2, divided by resistance of this complete branch, which is R6. In the previous case, or in the previous example, what we have? In the previous example, here, I have not explained that concept. How will be the I5 here? How will be the I5? I have taken this potential minus this potential. It is not like that. This potential, we are traveling from positive to negative. That's why its value will become minus in that particular case and plus in this particular case. Now here, we can find out its current by taking the reverse directions also. If this I4 I have taken something like this, I4 upward, then what will happen? If the I4 is upward, then what is the potential here? 0. 0, we are traveling from positive to negative, which is minus. 0 minus V4 minus